So let's build the gradient descent algorithm. I have imported two libraries, NumPy as NP and Matplotlib pyplot as PLT for plotting. So let's start with defining the function x square. How we're going to do it is a function f, which takes the value of x, and it returns x square. So that's how I've defined the function fx is equal to x square in Python. Then let's also define its derivative. The derivative will be another function which will take values of x and it will return. So we know the derivative of x square is 2x, so we will simply implement it like this way. And then I'm going to generate a lot of x values so that we can plot both the derivative and the main function. So let's say my x-axis is linearly spaced axis starting from -2 going up to 2 and 500 points on this axis. Now what I can do here is that I will quickly show you how the function looks. So we have a function, we have x-axis here, we have a y-axis is going to be the function that we have defined, and this is going to be labeled as main function. So let's just say this is function x equal to x square. And let me just activate the general plot settings here and plot it. So here we are. So this is the quadratic function, the error function that we are going to minimize. X-axis is horizontal, y-axis which is equal to x square is on the vertical axis, and so this is the function. Let's also plot its derivative. So it's going to be the same thing, and instead of main function it's derivative, and this will be 2x and derivative of this function. Okay, so let's just plot this, and here we are. 2x is just a straight line, so it's starting from -2 going up to 2. The negative x-axis is having all negative slopes, and the positive x-axis is all having positive slopes. The idea is that we have to come down to the bottom, to the minima of this curve using gradient descent algorithm. So far so good. I will just disable these plots, and on this graph, on this plot, x square plot, I need to choose a random x and then start from there converging towards the 0. So let me just choose a random point on the x-axis. So how it can be done is, let me call it xrand, a random x, and how I can choose is through this command choice. So from all the numbers on x-axis, I want to choose one number, and since it's going to be array, I don't want array, I want the first element of the array. So let's see how this number looks. Let me just print xrand, and essentially I am picking one particular number on this x-axis, and correspondingly I'll pick up the y value as per the function. So let me just disable the plot settings. So here we are. 0.34 is one random number on the x-axis that I've chosen, and this will be between -2 and +2. So next time I run it, it picks up another value. Next time I run it, it picks up another value. So it's random, as you can see, it's a random x value that it is choosing on the x-axis. So I am going to let's just say print. I also need to calculate the slope at this point. So let's say the initial x value equals xrand, and we also need to calculate slope at this point. So let me just copy this, and initial slope at initial x value is going to be nothing but differentiation of xrand. So let's see what is the slope here. I'm going to disable this now, it's no longer needed. So here it is. At point randomly chosen x value is -0.59, and the slope at this point is -1.19. So so far so good. In fact, since slope is 2x, so 2 multiplied by this value is what the slope is, and we are achieving this correctly. Let's just now, so we have to do a couple of things. As I mentioned earlier, that we have to set a learning rate, and this is a constant, a small value constant. So let's call it LR, and let's set it to a small value called 0.01. And also I have to decide how many number of steps I need to take towards converging to 0. So this is what will be used by for loop for the iteration. So n steps. Let me say I'm going to use 300 steps or 200 steps. 300 will be a slightly large number. And so this is how I'm going to initialize my algorithm. I will also initialize 2 arrays to save all the x values and all the corresponding slopes so that I can plot them later. So let me create an array called xrand. It will save all the x random values. So this is np zeros, and how many such numbers? I need as many number of steps that we have in the for loop. So it will create a blank array of all zeros, and I will also create a slope array which will store the intermediate slopes for all these x random points. So which is again be a array of all zeros for storing the number. So I will now perform this gradient descent. This is the main algorithm. So as I mentioned earlier, we have to start with a for loop because we have to iterate in multiple steps. And how many number of steps? In in range n steps, as we've said earlier. So this is what. So at every x rand point, I will have to calculate the slope. So let me just call this as slope. And how I'm going to calculate this is that I have my function df, which is calculating derivative of x square, and I'm going to pass on the x rand value, and that's how I'm going to calculate the slope at this x rand point. Now I have to update this x rand value and start. If I'm on the left hand side of the curve, I have to start moving towards right. If I'm on the right side of the curve, I have to start moving towards left. So I need to adjust my x-axis or x step accordingly. So my new x step will be as per the gradient descent algorithm, which says that old value of x, slope into the learning rate. So I will then shift my x step accordingly and hopefully move towards the minima point of the curve, error function, which is x square. And also I will save both the intermediate random values and intermediate slope. So how I can do it is I will just so every ith value will get stored in every ith location, and I'm going to store my x rand. I'm going to save my intermediate slopes in my empty array like this, slopes, so that I can plot them. I also want to, since I have seen the initial x value and the initial slope, I would also like to see what is the final slope and the final x value. Hopefully it should be all 0 if the algorithm is working fine. So I'm just going to print out these statements. And I will also plot these points on my curve. So if you remember, I had this curve. Let me activate the general plot settings and run this code. So we have an error. Okay, it's not NP0, it is NP0s. So let's correct that. So here we are. As you can see that we have initial value of x as 1.24, which will be somewhere here, x 1.24 somewhere here. So the corresponding y point is here. And then we will start moving in this direction by modifying our x steps so that we reach this point. I need to have a better visualization of what's going on. So to do that, I have already saved my intermediate x values and intermediate slopes in a function, in an array. So I'm going to use the same thing to plot. And this is what I'm doing is I'm taking all the x random values and I'm calculating the corresponding points on x square curve in blue color. And then I'm taking the same x random values and corresponding slope values and plotting them on the slope curve in red markers. So let's see how the whole thing looks now. There we are. So our initial value is 1.334, which means we are somewhere here. And as you rightly see, the y value here is this point, the starting point. And the slope at this point is 2.66, which is 2x. So this is the slope here, and I point this red marker is indicating the slope corresponding to this point. And then through various iterations in the for loop, using the gradient descent algorithm, I'm moving towards 0. So as I'm moving towards 0, this slope is also moving towards 0. And finally, I settle down at the lowest point of this error curve and achieve the minimum. So what is my final slope? Practically speaking, it has almost become 0. And what is my final x value? At almost 0x, I will get a 0 slope, which is what this data is showing. Let me just run it again to see. Now this is from the other side. My initial x value is minus 1.79, which is somewhere here, minus 1.79. So my point on x square curve is here. And from here, I start moving in the direction of 0. And accordingly, my slope continues to reduce until it reaches 0. So let me run it for one more time. Here we are. So this time I'm starting from the positive slope side, and again converging to 0. So I can, now I want to show you the effect of learning rate here. So I have taken a very small number. What happens if I take a very large number? That's the 0.1. It is still converging. So why it's converging is because I have my number of steps is large. Let's say if I change it to 100. So there you see, it is still converging, but it's not, following the slope line. If I still choose a even larger number, let's say 1, and there you see, now my point has started bouncing around on the curve and the algorithm has become unstable. Let me see if I can increase the steps again to see. So you see, it's unstable, it is not reaching 0, it is just bouncing around the curve. So that's the problem if you have a very small, if you have a very large learning rate. Let's correct it. Let's just put it to, say, a very small value. And let's see what happens now. So again, it is not converging because there are not sufficient number of iterations for it to, it's taking very, very small steps and then just stops there. So let me just try to increase my number of to 2000. And you still see that it is moving rightly towards the global minima, but it runs out of iterations because it's taking very, very small steps, so it runs out of iterations. If I make this slightly larger, and let's see what happens now. So here, since my step size has increased, my algorithm is having sufficient number of iterations available to it. In this case, about 2000 iterations, which is a very large number, so it's taking a lot of time to converge because the step size is small. And let me just right size it and bring down the number of iterations to 200. So here we are. If my step size is slightly larger, let's say 0.01, then it just takes 200 iterations for me to converge to 0. Let me just play it once again for you. Yeah, so the choosing of step size or the learning rate is an art, and there's no hard and fast formula for that. So this is how this whole gradient descent algorithm works. I hope you found it interesting.